Here at the outlet in Dunleer, we have various instrumentation. We're measuring the flow of water over the weir. We have a V-notch weir in place here, and we're measuring the flow of water over that weir. So here we have the Orpheus Mini and the Ecolog 500, and the purpose of these two instruments here is to measure the level of the water in the stream. And this is the instrument here. It's a long piece of kit that it's a vented pressure tube here, and basically at the end of this then there's a sensor, if I can pull it up here. So that's the pressure sensor there, and it measures the level of the stream, and it also measures the temperature of the stream. Okay, this is the staff gauge here that we installed in Dunleer. It was one of the first pieces of equipment that we installed, and the staff gauge is used to calculate the discharge of water over the weir, and it's also used as a reference point for the instrumentation such as the Orpheus Mini and the Ecolog. We created discharge rating curves at different levels of the stream, and based on the data we get from the Ecolog and the Orpheus Mini instrumentation, we're able to calculate the discharge of water flowing out of the catchment over the V-notch weir. That's the discharge part of it. We also have a kiosk here that we're measuring different analytes on a 10-minute basis, so it's high resolution monitoring that's going on here. And we're measuring such things as total phosphorus, molybdate reactive phosphorus, measuring nitrate, turbidity, conductivity and temperature. And all of this is being measured on a 10-minute interval, and it's being measured 24/7, 7 days a week. So it's high resolution monitoring, and this experimental design that we have here in Dunleer is repeated across all 6 catchments around the country. So here we have the Sigmatax, and the Sigmatax unit is a sample preparation unit for the phosphax. And what it does is it takes a sample of water from the tank with its probe, and then it sends that sample of water up to the sample jar here in the unit, and in the sample jar here the sample of raw water from the stream is homogenized using ultrasonic vibration. And once this sample of water is prepared, it sends a signal to the phosphax so that the phosphax can take that sample of water across and analyze it then for either total digested P or molybdate reactive P. And as you can see here, the Sigmatax is now in a countdown phase for the next sample. So it takes a sample of raw water in every 7 minutes, and it puts it through a homogenization process for 2 minutes, and then it sends a signal to the phosphax then to tell it that the sample of water is ready for analysis. So here we have the phosphax. The phosphax is from HAC, and the purpose of the phosphax is to measure the total digested P and the molybdate reactive P in the stream water. So the phosphax measures the total P and the molybdate reactive P every 10 minutes, and it does this using an alternate cycle. So on one cycle it measures the total P, and on the next cycle then it measures the molybdate reactive P. And how it does that is it uses acid and heat in a digestion step here in the cuvette, and it digests the sample of raw stream water here to give us either a result of total phosphorus or molybdate reactive phosphorus. So in any 1 hour we would have 3 results of total phosphorus and 3 results of molybdate reactive phosphorus on a 10-minute interval. So the data from those is sent back to the SC1000 controller, and we download the SC1000 controller every month. And then that data then is subsequently uploaded then to the server in Johnstown Castle for the research team then to go through the data. So that's how we get the data from the probes. The SC1000 controller then in turn is feeding into a Netrix system, which is a web-enabled Netrix system, and basically that's sending the data to a cloud. So we can go online then, and we can go and we can look at the data live from the kiosk, and we can also plot the data historically to see what the trends are.